Hi, it's Selim Kiganjani here, and today we are going to cover infinite geometric series. Infinite geometric series is part of the topic of algebra, and in Tanzania we are teaching this topic to Form 5 students actually who are taking basic applied mathematics. So with infinite geometric series, we know that actually we are talking of geometric series whose terms go to infinite. So we don't know exact number of the terms for infinite geometric progressions. So from the series we have here, dear students, we can see that with this one here, common ratio is 4. And with common ratio of 4, the terms become larger and larger as the number of terms n increases, and therefore its sum will increase rapidly. But for the second case, you can see that the terms decreases as number of terms increases, and it is because the common ratio was 1/4, dear students. So for the second series, when r equals to 1/2, we can say that for the case when r is 1/2, we can say that the terms of the series become smaller and smaller as the number of terms n increases. Its sum will be approaching a certain definite number, since the higher terms will be very small and those terms will all be approaching 0. So it is possible to discuss about sum to infinite. Sum to infinite, we denote it with S infinite, as you have seen here. When the values of r lies between -1 and 1, where r is a fraction such that r absolute is less than 1. Now we are going to recall this formula. As you remember this formula, we used this formula to find a sum of first n terms of geometric progression. And from this formula, we can recall now the case when n is approaching infinite. When n is approaching infinite, so we'll be having S infinite equals to g1 1 minus r power infinite over 1 minus r. So r power infinite is approaching 0, and so we can say that sum to infinite, dear students, will be equal to g1 over 1 minus r. So this is the formula we're gonna use always when talking of sum to infinity. So we can see that now the general formula we are going to use is g1 over 1 minus r, but we know that r absolute is always less than 1. So we're going to do 3 examples in this case. So convert the following recurring decimals to series and find the fractions in lowest term. So we have 0.05 and 0.05 solution, 0.05 repeating is equal to 0.0055555. It goes to infinity, and this can be rewritten as 0.05 plus 0.005 plus 0.0005. It goes to infinity. From here we can see that actually this is actually geometric series, and common ratio is 0.005 divided by 0.05, you get 0.1, and also we have the first term being 0.05. So we are going to find now sum to infinity, So finding sum to infinity of this series, finding sum to infinity, you're gonna use g1 over 1 minus r equals to 0.05 divided by 1 minus 0.1, 0.05 over 0.9. So sum to infinity, dear students, will be 5 over 90. You simplify, you get 1 over 18. Therefore, 0.05, repeating, this is equal to 1 over 18. So we have seen that actually this is how we converted a given actually decimals into fractions. Yeah, going to example number 2, we have 0.23 repeating. We're supposed to convert them into fractions. So for we to be able to convert this into fractions, again 2 and 3 were repeating, we can say that actually 0.23 repeating equals to 0.232323, it goes to infinity. So you can elaborate it more now. You have 0.23 repeating equals to 0.23 plus 0.0023 plus 0.000023, it goes to infinity. So we can see that actually this is geometric progressions, and we have g1 equals to 0.23. We have common ratio equals to 0.0023 divided by 0.23. So you have 0.01 is our common ratio. So having common ratio 0.01, now we are going to find sum to infinity. And sum to infinity, dear students, we're going to take g1 over 1 minus r. So sum to infinity will be g1, which is 0.23 over 1 minus 0.01. So I have 0.23 over 0.99. So sum to infinity will be 23 over 99. So to conclude, you can say that 0.23 repeating, dear students, this is equal to 23 over 99. And now we have converted actually the repeating decimals into fraction. Going to the next example, the sum to infinity of GP is 4 and the common ratio is half. Find the first term and the sum of the first 5 terms. So we're going to say that solution we have g1, we were given sum to infinity, so sum to infinity is equal to 4. We have common ratio equals to a half. You're supposed to find the g1 equals to how much, and also sum of first 5 terms equal to how much. So we can say that sum to infinity equals to g1 1 minus r, and from here we can say that g1 equals to sum to infinity multiplied by 1 minus r. So g1 will be equal to 4 in the bracket 1 minus a half. So you have 4 times a half, which is equal to 2. So g1 equals to 2, dear students. g1 equals to 2. Coming to the second part, we are supposed to find sum of first 5 terms equals to how much? So sum of first n term, we know that this is g1 1 minus r power n over 1 minus r. So we just focus now on S5. equals to G1, which is 2 in the bracket 1 minus a half, or 5 divided by 1 minus a half, of course. So we'll be having 2 in the bracket 1 minus 1 over 32 divided by a half. So sum of first 5 terms, dear students, will be 4 plus 2 times 2 over 1 will be 4 multiplied by 31 over 32. To simplify further, we'll be having 31 over 8. So dividing by 8 here, you're going to have will be 3 actually, and 7 over 8. So 7 over 8, you're gonna calculate by using any method you want. So 31 divided by 8, you're going to get 31 divided by 8, you're going to get 3.875. So this is how we are dealing with infinite geometric series. You can do as many questions as possible. I think this simple lecture is going to help you to do revision and understand the concept of infinite geometric series. So till next time, dear students, stay tuned for more other mathematics videos. I wish you all the best in your mathematics learning endeavors. Peace.